Solving quadratic equations, part 2. In part 1 of solving quadratic equations, we looked at the square root method. Now, that method is good if one side of the equation is a perfect square. So, you might have either x square or some linear function of x, something like x minus 1 quantity square. So, let me write down equations like that. X square equals 4 or x minus 3 quantity square equals 16. All of these could be solved using the square root method that was discussed in part 1. Now, in part 2, we are going to talk about one other method. So, these ones could be solved by the square root method. So, that's one approach. Today, we will talk about solving by factoring. So in this video, that's what we'll focus on. So we will solve by factoring. Now, before I get into the real mechanics of solving by factoring, I want to tell you why it works. I want to motivate you for the reason it works. Now, if you have two real numbers, say A and B are real numbers, if their product is 0, what can you say? One of them has to be 0, because if this is not 0 and that's not 0, then you're not going to get their product equal to 0. See, something like negative 2 plus 2 will give you 0, but negative 2 times 2, a negative times positive, won't give you 0. It will just give you another negative number. So whenever you have product of two real numbers equal to 0, then you can conclude either A equals 0 or B equals 0. So if I have a product of two factors, now this time, let me say I have two factors, x minus 2, x minus 3 equal to 0. Now, when I'm solving for x, I know x stands for a number. X is a number. I don't know what it is, but I know it's a number. So, a number minus 2 is another number. And here also I get one other number. Number minus 3 is a number. So, product of two numbers is 0. That means either the first factor, x minus 2 is 0, or the second factor, x minus 3 equals 0. And then I know how to solve these two linear equations. It's one step equation. I can say x equals 2 or x equals 3. So I have two answers. So in fact, I can look at the factors and conclude what my answers will be. They will just be the opposite of what I see inside the parentheses. So this is the idea. If you can factor, you want to factor and set each factor equal to 0. And that's how you can solve by factoring. So this works. This is a good method whenever it works. But not all quadratics could be factored. Just like you cannot find the factors of, or you cannot factor every integer. Some integers are prime. You cannot factor them. In the same way, there are some quadratics that you cannot factor. So that for those quadratics, this is not going to work. Now, let's start with an example. So example 1, I want to say x square minus 7x plus 12 is equal to 0. Oh, I should mention I'm solving. Solving means finding the value of x. So when I see a quadratic equation like that, the first thing I want to think is, can I use the square root method? Well, I can't use, because it's not just x squared. I have a whole big mess here. It's not a perfect square. The other thing I want to ask is, can I factor this? So can I rewrite my equation? In other words, can I factor that? And it turns out, yes, I can factor. I'm looking for a product to be 12. What two numbers can I multiply to get 12? I can do 2 and 6, but their sum is not going to be negative 7. So 2 and 6 didn't work. 3 and 4. So 3 and 4 will give me 7, but if I take negative 3 and negative 4, I'm going to get negative 7. So there are my factors, which means my answers are obtained by setting each factor to 0. So either this or x minus 4 equal to 0, which means x is either 3 or x is 4. So when you can factor, you would factor and set each factor to 0. Let's look at one other example. Say I have y square minus 3y minus 10 equal to 0. So this is really an exercise in factoring quadratics, which we have covered in another video. And this was actually covered in factoring quadratics part 1 because the leading coefficient is 1. So whenever you have leading coefficient of 1, you can write down your variable to begin with. And now you're thinking negative 10 as the product. So if the product is negative, I got to have a positive number and a negative number. And so I can get 10 in a few ways, but the first thing that comes to mind is 2 times 5. And yes, 2 and 5, they will give me 3. If I take, I need negative 3. So which means if I take positive 2 and negative 5, their sum will be negative 3. So that's my factorization. I have my factors. So now I can conclude that y plus 2 is 0 or y minus 5 is 0. So if I solve this, I get y equal to negative 2. If I solve the other one, I get y equal to 5. So the faster you can factor a quadratic, the faster your process is going to be. You're only one step away when you have the correct factorization. So let's look at one other example, call it example 3. And this time, let's say I have something like 4m square minus 9 equal to 0. Now, do I know how to factor this? Well, if I have only two terms with no linear term, then in the factoring video, we talked about this being difference of squares. We want to check first if it's a difference of squares. And you see that 9 comes from squaring 3 and 4m square comes from squaring 2m, which means if I have a square minus b square, I know it would be a minus b, a plus b. So my factors are going to be 2m minus 3 and 2m plus 3. So now I will set each factor to 0, 2m minus 3 equal to 0 or 2m plus 3 equal to 0. So it's a two-step equation. I will have to first add a 3 on both sides. So that's what I get. And then in the second step, I will divide both sides by 2. So m equals 3 over 2 is one answer. And here I will subtract 3 from both sides. I get 2m equal to negative 3. And then I divide both sides by 2. I get m equal to negative 3 over 2. So in this video, it's all about factoring quadratics. Say you have 7z square minus 2z equal to 0. Now this time your quadratic only has two terms with no constant term. So whenever you don't have a constant term, that means you have variable in each term. So you can factor that out. So you have z times 7z minus 2 equal to 0. So what are your factors this time? Now one of your factors is just z and the other factor is 7z minus 2. So it may happen, you may not always have two binomials. Sometimes you have a monomial. Nevertheless, it is a factor, so you set each factor to 0, which means you set the first factor to 0. So z is 0 or 7z minus 2 equal to 0. Now here you don't have to do anything. This is already solved. So z is 0, but here it's a two-step process. I will add 2 on both sides and then I divide both sides by 7. So I get z equal to 2 over 7. So there are these 4 examples that covered all kinds of factoring. You may have a factoring with leading coefficient of 1 but all the 3 terms, and sometimes you have only 2 terms. If you don't have constant, you can factor the variable. If you don't have the x term, then it might be a difference of squares. You may want to take note of that, and usually it will be. So then you can apply the difference of squares formula. A square minus b square equals a minus b times a plus b. If you're not sure about that, then please watch factoring quadratics video one more time. I think these should give you enough examples because it's really not new material but just an extension of factoring techniques. And then you have to go a step further. You set each factor to 0 and solve. And then it's solving a linear equation, either a one-step or two-step equation. And here are the practice problems for this video. There are 10 problems. And notice, the first 5 problems have a leading coefficient of 1. So you can factor them right away. But then the next ones, they don't have leading coefficient of 1. So those are the harder factoring problems. But look at the last one. The 10th one is actually easy because even though the leading coefficient is not 1, there's no constant term. So you should be able to factor the variable here. All right. Good luck on those problems, and I'll see you in the next video. Thank you.